Electro-optics. So we'll talk about photoconductivity, photovoltaic devices, optical sensors and encoders, and optical isolation. So there's this thing called the photovoltaic effect, where you make use of p-in junctions and let light shine on them, and it can actually cause current to flow through the junction. So those photons that are hitting it can have enough energy that they can create free electrons that can do the migration and create that current flow. So it's special kind of diode. And normally they're made from silicon in these. So what is the photovoltaic effect?
Any votes for Bravo?
Yeah.
What? I said beta.
Well, they say it is.
No, they say it's my book, it said B.
Oh, yeah?
Something got highlighted wrong there.
Yeah, because I thought that's a light emitting guy.
Yeah, but in the question pool, it was C, unless that one is wrong.
Conversion of light to electrical energy.
Yeah, that's what you would normally expect it to be. Although,
Well, that's what's keeping my lights on right now at home. So
huh?
I hope that's what it is, because that's what's keeping my lights on at home.
Yeah. Okay,
Yeah, they're small, they have different values.
that was seems wrong. Of course, yeah.
Yeah, it should be B.
I'm wondering if they have a different name for the reverse effect where it's generating light. Because that's also a photovoltaic effect.
That's right.
Yeah, I think in this case it should have been B. What absorbs the energy from light falling on a photovoltaic cell?
Electrons don't absorb energy.
Yeah, they do. That's how they become free electrons. They have to
The state changes, but
they have to
electrons
increase their energy level in order to get past the Fermi energy to the conduction band. And then when they recombine, they let it go because they're back to whatever the valence energy was with whatever they recombined with. Could be a different atom, so it could be a different amount of valence energy. Let me go back. F4. I want to look that one up when we're done. Okay, so most cells are going to produce a 0.5 volt output, pretty much maximum, assuming it's perpendicular to the sun and there's not dirty and there's no clouds and all of that good stuff. So usually you get, I don't know, 20% out of what you should get out of a cell or an array. What's the most common type of photovoltaic cell used for electrical power generation? Silicon. What's the approximate open circuit voltage produced by a fully illuminated silicon photovoltaic cell? What's the efficiency of a photovoltaic cell?
Delta.
Delta. Photoconductivity, similar but different, where light or photons shining on the material will change its conductivity. So you can have things like photoresistors or photoresistive cells, which change their resistance, photodiodes, phototransistors. And they're normally made from crystalline semiconductors. I think the photoresistors might be selenium, if I recall, like they used to make rectifiers out of in the day. I think the only place they use selenium now is in laser printer drums. I think that coating on the drum is selenium. What happens to photoconductive material when light shines on it? Which of these materials is most commonly used to create photoconductive devices? Optical isolation. We have optical isolators and optical couplers. It's typically an LED and a photodiode or phototransistor that are mounted such that
Excuse me a second, Bob. Did we mention the cadmium sulfide photoconductors?
no, it's not on the exam, but you're right. Cadmium
They're-
sulfide.
They were
Ones
commonly
are-
used in cameras, and they are a truly terrible device.
Yeah, but they've been around a long time.
Yeah, but a lot of interesting used cameras use those, and the camera has to be rebuilt because of that, or the cell has to be replaced because of that. But
Oh,
just uh, they're a thorn in my side. I just thought I'd mention in passing.
okay. The main reason for having them electrically isolated or physically separated is so that you can, potentially, and we'll talk about the relays, you can control a very high voltage or high current that's isolated from the control circuit, which could just be 5 volts or 3 volts or something. When you're talking very high voltages, you definitely want to keep that isolated from your control circuit. And normally you're going to see in what they call solid state relays are built this way. And normally they'll take 5 or 12 volts in and will control 120 volt AC. They have thyristors or SCRs in them. Typical circuit for the diode isolator, where it's just a photodiode so that the LED can illuminate it, or the phototransistor version where it kind of acts like the diode, except the current from collector and emitter is proportional to the amount of light. So instead of a switch, you can actually use it as an amplifier or controlled current device, where the diode is just on or off. What's the most common configuration of an opto-isolator or optocoupler?
D, of course.
Yep. Why are opto-isolators often used in conjunction with solid-state circuits when switching 120 volt AC?
Charlie.
Charlie. Solid-state relays are basically made that way. It acts like a relay, but it's not a mechanical device. So most of the time they're AC relays, although I think there's some DC ones, but most of them I've seen are for doing 120 volts, basically. So what is the solid-state relay?
Bravo.
E. Yeah, Baker.
Okay, optical sensors. You have shaft encoders, which you use in machine tools a lot to know the position. You also have what we call encoders, which most modern radios, if you have a knob, it's not turning a capacitor or a potentiometer, it's turning an encoder. In some cases, they're actually mechanical encoders where you're getting switches and you can feel them. Borns also make some that are, what do they call them, contactless, where it's a smooth feeling like it's a real optical encoder, but it's actually making electrical connections. In the case of the optical one, you usually have a light source and a photodetector or photodetectors, because there's more than one channel, and a mask. Usually it's a circular, they do it with a photo process, like a negative film. So it has little slits or clear areas where it lets the light through. Should be. And in the case of like an optical encoder, you usually have three channels. You have A, B, and Z, where Z is your index, and it only occurs at one point. So you know every revolution you get a Z pulse. But as you rotate it, then you get the A and the B, and they're out of phase, so you can tell which direction you're going. In the case of an encoder, like on a radio, you normally only have A and B. You just care about what direction it's going. You don't care how many, I mean, you're counting how many revolutions, but it's relative. Oop. How did I get that up there? Which of the following describes an optical shaft encoder?
Alpha.
Alpha. That's it. Piece of cake, right?
We're so smart now. Might be able to find my car.